So, good afternoon, room 17. One thing I was going to do here was start with demonstrating problem number 4 from the homework. I was asked to demonstrate it this morning, and you guys might need it too. So it's a ratio box question involving there are a total of 520 coins. The ratio of dimes to quarters is 5 to 8. And so to start out with, we are going to find out the number of dimes and then use that information to figure out the total amount of money that we have. So starting out, we know that we have and I'll kind of be rushing through this a little bit since the other class has already seen this and they're waiting. So we have a total in our ratio of coins of 13. And so we're trying to figure out dimes and quarters, specifically dimes. So we're going to set up our equation. And we'll just going to multiply that by 5 now. So that gets us to 13D equals 2,600, which is pretty easy to figure out by dividing because it's just a times 20. So 200 dimes is what we start out with. So we're going to figure out the total. We're going to use that information to figure out the total amount of money. Oops, and I blew it. So, okay, well, now I just have to write it out. Dimes. If I miss my button by just a little bit there and put a dot on the screen, then I can no longer do that. Okay, so then we take that and we subtract our total from the number of dimes to figure out the quarters. So that'd be 320 quarters. And then we would do 320 times 25 cents to get, spoilers, 8,000 cents, otherwise known as $80. And then our 200 dimes is 2,000 cents, otherwise known as $20. Giving us a total of $100. All right. Okay, mentally math. Let's get mental. Okay, going to give everyone a few minutes to get out ahead of me. We know the drill. Make sure my volume's turned up all the way. Ooh, there might be a question of whether the sound is going to play properly with the video. Well, if that doesn't work, I'll just put it up on the playlist for the other class, and I'll show it to you at the end. Okay, these seem pretty simple.
What's a decimeter?
A decimeter is 1/10 of a meter. It is the unit between the centimeter and the meter. So it goes millimeters, centimeters, decimeters, and meters, but we normally don't use the decis and the decas and the hectas, and we don't use those in real life, typically. Alright, so this seems basic. 33 6/10. And then this one, we're just boinging 3 to the right. 1, 2, 3. Boinging. 3,850. Then, well, 2 5/10 is just half of 5. So m would just have to equal 5. And then, yeah, 20 meters to decimeters would be times 10. So 200 dms. Then exponents! So I guess if it's exponents, we don't even technically need to totally simplify it. But if we're dividing by 10, that would mean we're just bringing down our exponent by 1. Which would be 10 squared, also known as 100. Then 75% of 24 is, well, let's see. 1/4 would be 6, so 6 times 5 would be 18. And 4 pints is what fraction of a gallon? Well, 2 pints make a quart, and a quart is 1/4 of a gallon, which is 1/4. So this would be 2/4, which is 1/2. Oops. 1/2. Let's see if I can do this in the corner. Gallon. Okay. Well, that looks so wrong. That's supposed to say 1/2 of a gallon, not 1/2, y'all. Just saying. So, they're just suggesting this sort of mentally math technique, once again, of instead of saying, 45 times 16, we could just say 90 times 8, which is really just 9 times 8 with a 0 at the end. It would be 720. A little while since we've done that, right? Okay. We did that. Okay, so if we look at the top here, our lesson today is geometric solids, which will be a bit different than our usual kind of lesson because this isn't really a lot of calculation, it's more of a discussion than anything else. And we're back. So if you're watching the video and you're wondering what happened, I tried to enable audio on the iPad and it stopped the recording in QuickTime. We just watched the video that is up on the Math Song playlist. So you should go there and watch that right now. And then come back to this if you like. Or just watch it when you're done. So if you'd like to go over to the math playlist, I think Ms. Benna, I'll probably have a link for her. If she wants to click on that, go there. It's totally fine. Okay, see you back here in a minute. Alright, okay. Okay, I'll assume you're back then. Alright, so today we are talking about geometric solids. So here are some examples of that. We've got the cube. Maybe I should get more contrast out here. Rectangular prisms. Triangular prisms. Cylinders. Spheres. Cones. and pyramids. All right. This is where I tried to find some kind of graphic to go with this. Like some picture of someone pressing a block into clay. The internet failed me. Imagine pressing a flat rectangular object into clay. So, yeah, say you had, oh, I don't know, like a ruler, a short ruler, and you press that down into clay. What would be the shape of the hole that was formed? Anyone?
A line.
So, 1, don't blurt. Please raise your hand. And 2, you are incorrect. Anaya.
A rectangular prism.
Yes, rectangular prism would be the answer for that. So, yeah. So, imagine you had just like a flat shape, like just the top of that, and you press it down to clay, you'd end up with an indentation that was in that shape. All right, so let's think about some of these. Use the name of a geometric solid to describe the shape of each object. And if you're watching the video in class, maybe stop the video for a second and let people in class answer this. I'll take one deep breath. Let you do that. Okay, Serena, do you want to tell us what would be a basketball?
A basketball is a sphere because it's in a round shape.
Good. Yeah, sphere. And thanks for also saying why it's a sphere. I like that. And we have a guest speaker from the other class. Anushri, you want to tell us about the can of beans?
It would be a cylinder.
Totally right. Okay, good job representing room 17. Uh-oh. My D's terrible here. There, that totally made it better, didn't it? Awesome. Okay. Okay, and the last one is shoebox. Rana, what do you think?
It's a rectangular prism because it's like a box.
I'm not gonna write that out. We were just looking at that word. Rectangular prism. Very nice. All right. Okay, let's talk about our friend the cube. So for starters, let's talk about the parts of it. That's what this one refers to. So the different surfaces on it, we would call those the face. Then the parts where two sides meet would be the edge.
Two faces meet.
And then let's see if we can find a better color. And then the spots where where edges meet, like where we what we call it when something makes an angle and where the two lines would meet, we call those vertices. And let's say like there, right there. So we call that a vertex, and plural is vertices. So that's basically where an angle is created. Okay, so faces. How many? So imagine this is a 6-sided dice. How many faces does it have? Does someone want to answer that question. Oh, don't raise your hand if you've already raised your hand. Okay. Oh, Unch, what do you think?
6 faces.
Mm-hmm, yep. So you 1, 2, 3. I'm doing the back one here now. 4, 5, 6. All right, good. Okay, so yeah, faces would be 6. Okay, and how many edges? How many edges? Who wants to answer that? So how many places where, let's get a nice contrasting color that we haven't used yet. Well, I guess I'll just use bright red. There we go. How many of these does it have? Let's see, I'm looking for people that have not raised their hand yet. Nora, what, you start raising your hand and not raising it? Okay, Siddharth.
It has 12 edges.
Right, so here we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very nice. 12 edges. Oh, yeah. Oh, 12 up here. Okay, and then vertices. Ooh, that's a tricky one. But Advi's willing to jump in.
8 vertices?
Uh-huh. Yep. Let's look at this. Let's see. Maybe make that one purple. Okay, so yeah, we got 1, 2, 3, 4, 5, 6, 7, 8. Ta-da! 8 vertices. All right, good job, people. While I'm at it here, let's also talk about the dimensions of geometric solids. So if we're computing things about the area of it, say, or just trying to describe it, so we've got, make this purple. So you've got how high up it goes is the height, just like if we were computing this as a 2-dimensional surface. And so then the other part of that 2-dimensional surface is the length, but then also we have this 3rd dimension. Oh, and different color. Make you orange. We've got this 3rd dimension, the width, which actually strikes me as a little bit strange that they actually don't have us computing the volume of anything on here. All right, so this next one, I'll make this a little bigger for you to start out with. So you try this at home or in the classroom. Draw a cube and then answer the following questions. Look at so first, draw a cube. I will also try to draw a cube. If you look down, though, I do have a backup plan just in case my cube is totally, absolutely terrible. I have plan B for my cube.
Okay, there's a cube has to be.
How, sorry? How deep?
How big?
How big? However large you want to make it. Okay. So I'm going to, okay. Maybe I will just bring out my cube. Okay, there we go. Give you a little dimension. Okay, I think I could do better than that. Oh, ha 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 ha! See what I did there at the top was I made a parallelogram. You see? I think I could do that here too. Parallelogram? Nope. Alright, try this one more time. Come on, give me a parallelogram. Okay, I'll try it for realsies one more time. That's not awful. If I had a finer tip eraser, I could get rid of some of my extra line there. Let's see, can I? Oh. There you go, buddy. Cube. Okay. Alright, and then let's see, maybe I'll make a little kind of lighter lines showing my dimensions in the back. I think I could even go lighter than that.
Or you could do dotted line.
Yeah, I could, but I like this idea. Oh! Look at my cube, guys! I'm proud of it. I'm not even going to use my backup cube. Okay. Yeah, that probably used way too much time. Okay, well that gave you plenty of time to make yours. Alright, so look at one edge of the cube. Okay, I'm looking at... let's see. Maybe I'll look at this one. Okay, so how many edges are perpendicular to that edge and how many are parallel? Okay, so the perpendicular ones I can see are there that intersect at 1, 2, and then there's 2 at the bottom. 1, 2. Okay. So that would be perpendicular would be 4. Then how many parallel to it? So, well, let's see. It looks like there would just be nice value green. Do I have a bright green? Can't believe I don't have a bright green. Okay, I'll just use red. So parallel to that, I guess, would be that one. And man, it really doesn't want to put that line where I'm trying to put it there. And that one in the back. Oh. And you know what? This one over here on this edge is also parallel to it. So, well, I guess all the other sides are parallel to it. Aha!
Mr. Petrie, would this side, can I annotate? Because, like, the side underneath many, what would that be parallel or perpendicular?
Oh, you mean, I'm gonna use purple. You mean this side?
No. The one underneath many.
You mean,
many.
this side? I think, so you're talking about this one, right?
Uh-huh.
I think that one would actually be skewed. Because it's never going to intersect it, and it's not parallel. Yeah, I would have to say that one's probably skewed because it has no intersection point with it, and it is not parallel. So it kind of doesn't fall under anything.
Okay.
Alright, so let's see. Getting rid of those. Look at... Oh, get rid of that guy. Look at one face of the cube. Okay. Well, maybe I'll use this face because then it's kind of easier to see all the other parts to it. Okay. So how many faces are perpendicular to it? Okay, so, well, I think it's kind of the same sort of thing. So this would be perpendicular to it. The guy down here would be perpendicular to it. The one on the back would be perpendicular to it, and the one on the front would be perpendicular to it. The only one that is not perpendicular to it would be this back one here. So the answer for this one would be 4. And then how many would be parallel to it? Well, the only one that could be parallel to it is the one on this other side. So the answer to that would be 1. Okie dokie. And hopefully you were kind of figuring that out faster than me. Alright, so which of these patterns do not fold to form a cube? So, instead of, just to give a little context, hopefully, we don't need sound for this, so this is what they're talking about doing. So you take some paper. So you made one of those. Say they're 2 inches. Cut it out. And then you fold it. And then you make a little box out of it. Ta-da! Cube. Okay, so looking at these, and hey, I think it's kind of a funny coincidence that none of these are actually the cube that they made. So you could do this a lot of different ways, but which one do you think would be the wrong way that's not going to make a cube?
Can I answer?
Yeah, Nora, you're the one that hasn't raised your hand yet.
A.
A? You are incorrect. A will in fact form a cube.
Wait, isn't it asking which one will form a cube?
No, which one will not form a cube? So, do you want to modify your answer to which one's going to come out just wrong?
D.
Yes, very nice. Would you like to say why?
Because it's built that way.
Okay, fair enough. If you really want to find the answer to that, you can try it at home. But yeah, we sort of need to wrap this up so we can work out our problems. Okay, then for this last one, if each edge of this cube is 5 centimeters, so I'm going to let you guys try to figure this out faster than me. All right, so the combined area. Oh my, and this is the sort of thing that shows up on tests and CTPs and that kind of thing. And it's really not hard at all. So if each edge is 5 centimeters, then what is the surface area of all of the combined sides? All right, I'm going to let you get out ahead of me on this. It is definitely not rocket science. Maybe I'll let people guide me on the steps that I should take to solve it. So I'm gonna let people just figure it out. Okay, it's 2 simple steps. It definitely is not anything you don't already know or can't see right in front of you. I'll assume that was probably enough time if you know it. So, Veer, what would be my first step?
Because each edge, so if it was a flat surface, to find the area of one side, you would do 5 times 5.
Okay, good. And stop. Yes, so first we want to find just the area of one edge, and so that would just be, well, 5 squared, because You know, it's a square. So that's 25. And since there are 6 sides to this, what do I do, Arjun?
You multiply the area, which is 25 by 6.
Mm-hmm. Oh, I should say centimeters here, shouldn't I? Centimeters square. Okay. Yeah, and then just times that by 6 to get... You want to tell me, Arjun?
150 centimeters squared.
150 centimeters squared. I'm surprised they didn't ask a volume question on this, but they did. Okay, I'm going to stop the video, and we're going to get to work on the written practice.